Welcome to today's StarWind webcast. This call is being recorded. And now to begin the program, I'd like to introduce Chris Flack. Mr. Flack?
Hey, thank you so much, Greg, and welcome everybody in our audience to today's webcast, Hyper-Converged or Compute and Storage Separated, which is best for virtualization, sponsored by StarWind. I'm Chris Flack with Redmond Magazine, and I'm here to be your host for today's event, so thank you all for joining us. Just a few quick things before we introduce our presenter for today's webcast. We will have a Q&A at the end of today's session. However, we do encourage you at any time during today's presentation to enter your question via the Ask a Question box appearing on the left-hand side. And hopefully, if time permits, we'll get to everybody's questions and get out some answers. Also, today's webcast is being recorded and archived for future viewing purposes, and we'll send you a link to the email you registered with within 24 to 48 hours after today's webcast. Joining us for today's webcast, we have a really great presenter. His name is Chris Evans, and he is founding director of LangtonBlue. Chris is a noted author and a noted webcast host, just like on the one you're about to hear right now. He has over 25 years' experience in IT, mostly as an independent consultant to large organizations. He's a prolific blogger, as I mentioned, and his musings on storage and virtualization can be found at thestoragearchitect.com. And for more information on Chris's company, LangtonBlue, you can go to langtonblue.com. And with that, I'm going to hand everything over with Chris so he can get started with his presentation and a little bit of what you'll learn today. So, Chris, why don't you take the floor and get started?
Okay, thanks very much, Chris. I appreciate that, and good morning and good afternoon, everybody. As Chris has mentioned, we're going to talk today about hyper-converged solutions or whether we should have compute and storage separated. So let's just summarize what we will do in this presentation and what you'll learn. So first of all, we'll talk about the idea of hyper-converged and non-hyper-converged solutions and how they fit for virtualization. We'll look at some of the issues that exist with traditional non-commodity or monolithic storage, some of that legacy storage that people still have in their data centers. And we'll look at some of the issues, of course, with the hyper-converged solutions. We'll then go on to talk about the newer style of technology, what you might call commodity or scale-out solutions. And we'll talk about those in detail, and we'll talk about how the architectures are different. And we'll also look at some of the vendors out there. So perhaps we'll talk a little bit about virtual SAN, and we'll talk about some of the monolithic platforms too. So that's what we hope to get through today. So let's just skip over past my slide, and we'll start with the definition. So let's talk about what hyper-converged solutions actually mean. So when we talk about hyper-converged, we're talking about a consolidation of the hardware that would normally be separated, so storage, networking, and compute, into a single server footprint or a single node footprint. We use the term nodes because these pieces of technology are comprised of multiple nodes, and all of that technology is combined inside it. And these solutions scale by adding more nodes to a configuration. So you may, for instance, start with, say, 3 nodes and scale that out by adding more physical servers, adding more nodes. This is very similar to the way in which some of the large companies like Google, Facebook are deploying web-scale applications, where the node effectively is the unit of deployment, rather than it being within a server or within a storage array. And ultimately, these solutions exist because they have a secret source built into the software. So the effort's been put in to developing the software and pushing features that would traditionally be in the storage separately into the actual merged components. So that includes things like data protection, data efficiencies through thin provisioning or perhaps dedupe, and they've all been pushed into that one component in software. Now, one way of looking at this is to look at it and think this is very similar to the way that the mainframe vendors might have deployed things many years ago, and typically a lot of the time, because it's all being combined together, these components are all being sold by one vendor. And if we look back at the way the mainframe was deployed, that was pretty much the way that technology was deployed quite a few years ago. So let's move on. Let's just try and represent what we mean by this idea of hyperconverged in terms of components. So if we imagine how we would build up a hyperconverged solution, we would look at it in terms of a form factor of a server. And I've shown there just a simple rack server, as you can see. And these solutions would be made up of the typical components that you see in that sort of architecture. There'd be some CPU or processor. There would be some networking, and that would be perhaps done through a 10 gig network for performance, but a lot of solutions will still work for 1 gig. There'd be memory in that solution, and having server memory, we can use that, as we'll see and we'll talk about later. We can use that for caching functionality. And of course, we need some storage. And a lot of the solutions that are hyper-converged today will use a mixture of disk storage and flash storage. The combination of the two really is all about getting performance out of the solution. Flash can be used as both a cache and as permanent storage, and of course, disk is there to provide the permanent bulk capacity. So if we put all that together, we end up with something that looks logically like this. We have a set of physical servers which potentially provide, say, virtualization through a number of different hypervisors. Obviously, VMware's vSphere, ESX, and Hyper-V are probably the two that people know the most. But we also have KVM in there as well from some vendors who are using that to cut down on the cost of putting in the hypervisor. What that gives us is a shared pool of storage, a shared pool of memory, and a shared pool of compute resources against which we can deploy our VMs. And quite critically here, as you can see in green, we have shared management tools, shared interfaces, and shared APIs. So we can manage these solutions uniformly. So what can we expect out of hyperconverged, and why were people doing this in the first place? Well, what we'd expect to see is clearly from a scale-out architecture like this, we expect to see performance. And one of the reasons for that is that we're moving resources closer to the processor. The storage resources are closer, and therefore we're reducing our latency. We're distributing our workload across multiple nodes, so we've got the benefit of a distributed architecture. And of course, we're eliminating things like the fiber channel and Ethernet storage networks, and that allows us to use cache memory and PCI devices within those servers as a cache device, and therefore we can reduce our latency and improve our performance. We'd expect to see some sort of scalability, and obviously we achieve that, as we've mentioned, through adding nodes to the configuration and distributing that work across all of those nodes. So each node adds to the processing power and the number of IOPS we have on a cluster. A lot of these solutions are deployed with data efficiency technologies, so we see things like thin provisioning, compression, deduplication being introduced, all of which are there to try and reduce the amount of storage and improve the actual experience for the user. Of course, we would expect there to be data protection, and data protection would be something that was traditionally deployed within a storage array. That functionality now has to exist within the hyperconverged solution, and that potentially can be done in a number of ways. Some solutions using distributed RAID, some simply mirroring or replicating a VM or LUNs within their configuration. But of course, what happens is we have a failed domain ultimately that becomes the node. So it may well be that if we lose a number of disks in one of these boxes, the whole node is taken out. And it's that very different scenario of what people call pets versus cattle. As we'll come on and talk about the monolithic world, that's very much like the idea of having a pet. You want to look after it, you care for it, you look after it. The hyperconverged solution is much more like the idea of maintaining cattle, where you're not really connected to each one, and the loss of a node isn't really treated as being a big issue. We expect, of course, to see a lot of management software here because we're deploying a solution where the software is meant to integrate all of these components, and we see integration from these solutions into the typical hypervisor solutions like vCenter or into Microsoft's Virtual Machine Manager. Management also leads on to reporting, and clearly because of the fact that we're putting in all of our resources into the set environment here, the set number of servers, we have to do all of the typical reporting and capacity management and alerting that we would have done if we had the storage separate. And that also applies for security because we would still need to encrypt data even though it's inside the server. Licensing, just as a side note there, we just mentioned it briefly, typically can be done either per node or on a capacity basis. So Obviously, that leads us to a question that says, are there any issues with using a hyper-converged solution? Well, clearly, there are some trade-offs here. And the first one is to say that typically the storage is tied into that solution. Now, some solutions is absolutely tied in and you can't share that storage anywhere else, whereas some software-based solutions may allow you to share the storage. However, typically that's not really the intention. The intention is to provide a converged solution that is actually standalone and doesn't share any of its resources. Some solutions expect that the growth is done through identical nodes, so as you scale out, you have to scale the same node type. And that comes down to creating a small problem in that if you need to scale either storage or compute, you potentially could be in a position where you could waste one or other of the resources if you're forced to scale in a consistent manner. So you may find that you want to scale up or put another node in because you have the need for more storage capacity, but you don't need more compute, but you're still required to buy a complete node which offers both features. Of course, scaling up to the enterprise size of capacity would require many nodes and many clusters. Of course, that then introduces additional management overhead. And one thing we have to bear in mind here is that if any performance issue is experienced, and that could be because of a disk failure or a need to rebuild data if something happens to a node, then we may see a significant performance issue as the cluster rebuilds and redistributes that data. And of course, because we're sharing the same CPU for compute as well as storage, that could have a direct impact on the hypervisor and on the guests that are running. And finally, one thing we have to look for in these solutions is to see whether the features that were in traditional monolithic arrays, such as data scrubbing, auto rebuilds of failed devices, predictive sparing, where the system would identify a disk and copy the data off before it failed. Not all of these features have been pushed into hyper-converged solutions yet. So there are still some gaps around that we have to be very careful about. So now let's go on and talk about the idea of what people might think of as a traditional way of deploying storage in virtual environments, and that's to have the compute and the storage separated. So what did that look like? Well, traditionally, we would have one or more storage arrays, depending on the scale of the customer's environment. Those storage arrays would sit within the configuration. They could be dedicated, or of course they could be shared with other pieces of the infrastructure. Sitting on top of that, we perhaps have some sort of network, and obviously fiber channel is a big player in the enterprise. We see a lot of that, but of course we can still deploy on technologies like iSCSI. And we've seen SCOE being deployed in converged solutions which just plug all of these components together. And finally, sitting at the top of that, we have our servers, which could be virtual servers, virtualization environments, or they could be standalone servers, but effectively we're separating the three. So what do we mean when we say compute and storage separated? Well, we're saying the hypervisor and storage components are physically separated, and depending on what type of model we've got, that could be dedicated storage equipment, or we could be running some software that allows us to use traditional hardware, the same hardware as our server hardware, as the building block for our storage. What we're then going to say is that, of course, the storage is configured separately from the hypervisor. So that means the actual management task of configuration is done separately. It's not part of the same infrastructure. It's not part of the same management process. Of course, one positive benefit there is that the storage isn't required to be dedicated to the hypervisor, and we could assign it to one or more hypervisors. We could assign it to other standalone systems, or in fact we could use it for other things like NAS or something like that. Typically, with the more monolithic, the more traditional legacy solutions, we've seen a lot of additional features being built into the platform. The sort of things we've seen there, of course, are things like replication, which could be both local and remote. Support for additional functions like the AAI for vSphere, which is an offload capability, and we'll talk about that in a moment, and other things like thin provisioning, deduplication, and compression. What we have seen, of course, is that in the more legacy monolithic type configurations, some of those features have been delivered as an add-on, and they weren't originally part of the infrastructure. So, of course, some of them don't work as efficiently as the more modern solutions which are deployed scale out. And we'll talk about the difference between those in a moment. Of course, we're splitting the processing, so the servers and the storage have both got their own processor environment. They're not likely, they can't affect each other. So, of course, when the storage array has a problem and has to sort something out, like rebuilding data, that doesn't have a direct impact on the processing of the hypervisor layer, unless, of course, the problem is so severe that it actually causes some sort of response time issue from the storage. And we talked there about heavy lifting. Now, this was one of the things about VAI that we were just discussing there a moment ago. And this was introduced as a way of taking some of the offload, some of the overhead away from the processor and pushing it down to the storage array. Now, there's some benefit in doing that because clearly the array itself can make some decisions about how it, for instance, copies data or how it zeroes data out or how it locks data. And that can obviously give significant performance improvements if the array is allowed to do that task alone. So we'll just finish this slide and just talk about the fact that what we've discussed there could be delivered in two ways. So we could look at it from a traditional legacy environment, what we might call a monolithic array, or legacy arrays that are built around custom or at least bespoke hardware, or we could be talking about more modern scale-out storage architectures that are being built around commodity solutions. And that's what we'll come on to talk about in a moment. So let's talk about monolithic. When we say issues here, we'll discuss some of the actual characteristics as well as some of the issues. And when we say monolithic, we're talking about arrays built on legacy architectures. So these are architectures that have been around for maybe 20 years or more. Typically are built on dual or multiple controllers, and they have a high level of component redundancy. So the idea is that they build as much redundancy into that array as possible because at all costs they don't want the array to go down. And that might be through additional power supplies, or it might be through multiple components like adapters, internal adapters, internal bus adapters, and so on. The idea is to keep that array running at all costs. So at the enterprise level, you know, we've seen technology from EMC, from Hitachi, from IBM, and in the mid-range, of course, there are similar products from those vendors as well. What we are seeing, just as I guess as a side note here, is that a lot of these vendors are moving to replace what were originally very much bespoke components. And we're now seeing those vendors migrating towards more commodity-type deployments. But of course, they're still retaining some custom hardware in there because there's still some things they just simply can't do in order to provide what is really the benefit of those solutions, and that's high availability. So, of course, one of the things that technology is potentially, first of all, they're expensive to acquire. They're much more expensive than, say, a scale-out solution based on commodity hardware. The hardware is expensive to acquire, and potentially so are the skills. And that means paying storage administrators and other people to design and deploy this technology quite high salaries. These are well-paid people. And that can be a problem if you've got a very high-growth environment. We should remember that, of course, because we've got a single device, all of the data exists on the same physical infrastructure. So typically, in order to achieve DR, and by that we mean disaster recovery, we would have to place another array in another location. And we would use the proprietary vendor technology to do things like replication. That pretty much means that you can't really use this solution for the cloud, so you couldn't replicate your VMs to the cloud if you wanted to take advantage of the vendor's hardware. Now, there are some scenarios where that's changing, and we can point to, for instance, NetApp, who've put some of their technology in the cloud and allow people to replicate to that device. But not everybody's gone down that route, and of course that would require all the vendors to put technology in just for their customers. These solutions do scale, but and they scale in capacity and performance because obviously they're high-end, expensive technology. But what they also do is scale in complexity. So as you add more and more capacity to these devices, some of which can be, for example, up to about 4 petabytes in capacity, what we see is we have complex management in terms of creating LUNs and understanding the layout of the device. And obviously we also have complex workload prioritization schemes. And what we mean by that is, we mean technology that actually moves data around on that array between different tiers of storage. So moving some of it to flash, and then moving some of it to maybe some high-performance disk, or maybe down to the low-end disk. And that can become a real problem because trying to balance that workload and understand that data is very difficult. The actual hardware doesn't really have any idea of what the data is, and it really is to a certain degree depending purely on just looking at the activity of the blocks coming through. Many of this technology doesn't really align with virtual platforms, and until next week, of course, when we have VMworld and we have the announcement of vVols and vVol support from various customers, what we see is that we still have the idea of a LUN when we deploy on these technologies if they're a block device. But we really want to deal with things at the VM level. And the LUN could be a very large capacity device, multiple terabytes, whereas the VM would be a lot smaller than that, and that misalignment can be a problem when we're looking at things like replication technology and so on. Typically, these solutions don't integrate well with the hypervisor because they were originally designed to be standalone, to be configured by the storage administrator. So they don't necessarily integrate well. And we've seen obviously plugins be developed for that sort of feature, but they're not as advanced as some of the more modern technologies that are out there. And of course, one thing to bear in mind, comparing this to hyper-converged solutions, if we look at it, we still have a storage network latency here. So if we want to accelerate the performance of those boxes past that latency of the network, then we have to look at cache software and potentially hardware in the host, in the virtualization host, to achieve that, even though we've got a fast storage array. So let's now talk about what has been called scale-out storage. And this idea is really to do something very similar to the way we've talked about hyper-converged or web scale, and that's to use multiple nodes to deliver our storage. So we have multiple servers, all potentially commodity defined, and either we can get a hardware solution or we use a software solution, but effectively we're using multiple hardware nodes and we scale it out, and each of those nodes has got storage in it in a similar way to the hyper-converged solutions. These technologies can provide block, file, and object storage. So we see a lot of the vendors coming out with the block solutions and file solutions, which obviously are good for the virtualization environment, but quite a few are also coming out with object-based storage. And if we look at the way that's developing, some of the object-based vendors who you potentially might think were looking to deliver technology to sort of an archive-type solution are potentially looking to their platforms being primary storage. So I think we'll see an evolution of that as time goes on, and we'll see the object providers trying to get closer to primary storage, especially in virtualization in virtual environments. As with hyperconverged, resiliency and scale is achieved by adding nodes to the configuration. So we add another node with more storage capacity, but of course the difference is that every one of those nodes is purely dedicated to delivering storage. We can achieve some kind of geographic resiliency with the object solutions, and that's pretty much done using technology like erasure coding, where the data is split up and distributed across many nodes, and it can be rebuilt from only a small number of those nodes and effectively we can tolerate node failure, or we can tolerate the lack of latency from the remote nodes. So that gives us the ability to be geographic with that, which could be quite interesting as we go forward if that technology does improve in terms of performance. Hardware refresh can be achieved by adding new nodes and decommissioning the old nodes from the configuration, which is a nice flexible way of upgrading. So if you started out with a solution that maybe was based on a certain capacity disk, and the vendor comes along and cannot offer you double the capacity in the same box next year, then over time you could just replace the new nodes. You could add new nodes to the system, and you could over time decommission the older, smaller ones, and it doesn't change the configuration. You're effectively upgrading the environment without having to take any outage and without having to move data on a bulk basis. Now, I did say that these solutions can be hardware and software based, and we see both from the vendors. So we see vendors selling solutions that are hardware based and contain both the software and hardware, and you buy nodes, and that's how you acquire the technology. However, there are software-based solutions out there which will do the same thing, and then it's down to the customer exactly what technology they put that on. We'll talk about some of that, the challenges of that as we go along, and talk about some of those vendors. One final thing just to talk about on this is that we're seeing a lot of this new technology coming along with API, CLI, or REST sort of based interfaces. The benefit of that is, of course, we're not dependent then on configuring and managing this environment with storage administrators. It doesn't become a static task to provision storage. And as we move forward, one of the benefits of using a scale-out solution and having an actual integrated REST-based interface is that we can integrate that very easily into virtual environments and potentially into cloud environments, and just have the storage provision the LUNs or the objects that we require at the time. And that's a big selling point for this sort of technology, and it's very different from the way that it was done within the monolithic environments. So what would this look like, this technology to the end user? Well, of course, physically, we're talking about just seeing many physical servers. And if we were looking at the data center as it was, if these were all separate storage arrays, we just see something looking very similar. So physically, we're just deploying lots of separate boxes. However, from a logical construct, what we see LUNs, or hopefully vvols in the near future. We're seeing vvols or LUNs that are logically presented across that entire infrastructure. So whether we take a node away, whether we add a node, it doesn't change the way we access the data. It doesn't change our need to understand where that data is on the configuration and move stuff around. The scale-out features handle all of that side of things in the background, and we just scale up what we want to do in terms of capacity. So let's just summarize that very quickly and just talk about some of the points. As we said, capacity and performance managed through the addition or the removal of nodes. And those nodes are obviously can be a lot cheaper. They can be a lot easier to deploy. A lot of vendors, for instance, will base it on 1U pizza-style servers, which are cheap, and therefore the upgrade cost and the incremental upgrade cost is quite small. Nice and easy to deploy. Workload is distributed across all of those nodes, and therefore every node is contributing to delivering the capacity. And a difference to the monolithic environment here, if we lose a node, then we only lose that percentage of processing power and capacity across the environment. To give you an example, imagine a configuration that had 10 nodes. If we lose a node, we only lose 1/10 of the configuration. If we had 20 nodes, we only lose 1/20 of the configuration. So the more nodes we add, the less impact a single node failure would have on that configuration. Now contrast that to a dual controller architecture legacy environment, where if we lose a controller, we pretty much lose half of the configuration in terms of performance, but actually it can be worse than that, because those environments were reliant on 2 nodes to synchronize their write cache, and pretty much performance just dies completely. So the loss of a single node in those environments was absolutely catastrophic. With the scale-out solutions, loss of a node is much less impactful than it previously was. Many of the mature solutions, as we talked about, would allow asymmetric node types. So that means we can sort of overcome that issue of whether we grow by capacity and performance. And in fact, some of the software solutions can actually cope with very, very differing server capacities and performance, and are able to deal with that and still deliver a consistent response time. The process of migration is much more simple compared to monolithic. We can pretty much add in a node and take nodes out, and that we can use that as our upgrade path, whereas with some of the monolithic type arrays, migration from one box to another could turn out to be a massive project in itself, costing a lot of money, having a lot of impact, and so on. And as we said, getting back to it and summarizing it, in reality, a lot of these architectures are very similar to the hyper-converged solutions. The difference is we're not tying the processing of the VM to the storage, and we're separating those two out, which means both of them can grow independently, and if one has a performance issue, it doesn't directly affect the other. So who's doing this technology? Who's out there with these kind of solutions? Well, we've seen Dell deliver their EqualLogic technology, and that's been around for quite a while now. EqualLogic was acquired by Dell in 2007, and this was one of the first scale-out platforms for storage. And they do exactly as it says. They increase the capacity through addition of hardware nodes. So you pretty much stick in a new node and away you go, and that's the way that the EqualLogic technology works. One of the newer vendors in the marketplace at the moment is a company called SolidFire. They've been around a few years. They're, I guess, what you'd call a startup vendor, and their solution is built on 1U servers, which you start with a minimum. They recommend a minimum of 5 in order to give the resiliency, and their connectivity is all based on iSCSI. So initially, this was an iSCSI-based solution for connecting to servers, and they really targeted the service providers with their technology. They've got customers who potentially have scaled up to 100 nodes in a configuration, which obviously is a very large environment. They recently added fiber channel support, so one node can be a fiber channel node, while the rest is still iSCSI, so they can start to support fiber channel environments. But I guess that's an early days thing. But you can actually even run fiber channel and iSCSI to the same LUN. So if you've got the most bizarre configuration in the world and you want to achieve that, it's still actually possible to do. So they're an interesting company to watch over the next few years. Nimble Storage is another company that's recently iPod, that was a startup company, and are now Puzzle. And they've come out with a file and block solution, which is quite an interesting architecture. It uses something called CASL, which is their sequential layout architecture. So basically, they convert random I/O into sequential. Not surprisingly, I mean, they're very close in terms of their architecture to the idea of the way that NetApp works. So of course, NetApp are very interested in talking to them about some of the patents they've got on their technology. But ultimately, their technology scales up and out, so they can add additional disk shelves to a single node, or they can add nodes as well, and that allows them to scale in 2 directions depending on the requirements of the customer. Next on our example list, and these are, of course, just examples. There's a wider market than the ones we're just quoting here. And the next on this list is 3PAR. Now, it may well be thought that 3PAR is a traditional storage array, but in fact, the architecture was built to cater for features like thin provisioning and so on, right from the very beginning, and that was all part of the architectural design. The solution is based on multi-nodes, and you put them into the environment in pairs, and data is distributed across the nodes, and all up to 8 of the nodes all deliver to the configuration. So it's a scale-out solution, which of course now can be deployed with an all-flash environment. So you can actually get an all-flash 3PAR array. And finally, as we're talking about all-flash, we have a company called Caminario, again another startup company. deploying an all-flash solution based on nodes. And the Caminario K2 platform can scale again, both open scale out. So you can grow an individual node, or you can add nodes to make the configuration more resilient and to grow it too. Very interesting way of doing it to give you both scenarios, because obviously that gives you the ultimate flexibility to add capacity to your environment. So let's talk about software, because clearly not all of these solutions have to be hardware based. And first of all, I guess we should put out a note to our sponsors for this presentation, and that's StarWind, and they have an iSCSI target solution which has been evolved into their virtual SAN platform. And this is both scale up and scale out in software, deployed on the Windows environment, and provides high availability support for vSphere and Hyper-V environments. We also have VMware and their virtual SAN platform, and this again is distributed storage, but of course it's slightly different in the fact that it has to be deployed within a vSphere cluster, so you wouldn't necessarily deploy this as a separate storage solution. We'll be interested to see what comes out next week when we hear about vVols at VMworld, and see if there's any integration or any connectivity between vSAN and vVols. Next in the list of examples of software companies is a company called Scale.io. Now, this company has been around for a while, but was very, very recently acquired by EMC. Scale.io have developed some software which you can deploy in commodity servers on Linux environments, and you can use JBOD storage within, and by JBOD we mean locally attached disk, JBOD storage within those servers to build a scale-out storage cluster. The solution is capable of supporting hundreds of nodes and scaling out to terabytes of capacity. And EMC and Scale.io are talking about some incredibly good performance and capacity figures. We've seen EMC take this platform, this software, and very recently they've integrated into their ECS platform, which is their elastic cloud storage offering. And this is their attempt to try and come out with a private cloud storage solution to counter the likes of Amazon and Google, and try and give customers something on premises that they can use, which delivers the same level of price point as doing storage in the cloud. Then we've got a couple of open source examples here. The first one being Gluster, which is now resold as Red Hat Storage Server. This is a distributed file system which pretty much just relies on the file system that's on the servers you deploy it on, but it adds functionality that builds in features like replication and protection, and that gives you the scalability. It's a very, very simple solution, but Red Hat are obviously hoping it's going to be popular as a storage server. And finally, on our examples, there's another company recently indirectly acquired by Red Hat, and that's a platform called Ceph. And the company who promotes it are called Inktank. They were acquired by Red Hat. Ceph is a bit more than just a simple storage platform. And in fact, it's a scale-out object file and block store that pretty much works in a similar way. It uses commodity servers, JBOD storage. It can use Flash in there. But the way that it works is that it presents, it stores all of the data in one format, and then it uses interfaces to present storage as either block or file or object. This one could be very interesting if it gets more traction, because it has the basis for delivering the same sort of functionality as things like Scale.io. So it could be a very interesting platform indeed. Finally, I think we'll just summarize what we've talked about and just go back over what we've talked about in the presentation and what we've learned. So first of all, we said, should we have converged or should we have separate storage? Well, if we have a converged solution, then potentially we could look at it and say it's simpler, less moving parts to support, integrated and supported by one vendor. We don't have to have two pieces that we have to support there. Storage is more closely integrated with the hypervisor, and that could be good, because as we've seen, we could benefit from increased performance through lower latency. And this typically is a good fit for perhaps SMB or medium-sized businesses who don't have the scale of enterprise, don't necessarily have all of the support teams to be able to support separate storage and networking, and just want something that's a lot more simplified. So it's potentially a very good fit for those organizations. There's still a place, obviously, for our non-commodity monolithic hardware, which is obviously very practical for very large-scale environments, and certainly for environments where storage is used for other things, where perhaps there might be some direct connect servers, and where perhaps ultra-high availability and where service-level objectives are very important. And pretty much that's what you're buying with that technology. You're buying that level of reliability, that 100% never go down type level of reliability. And if that's important to you, and you know that meets your business needs, then perhaps that technology is still good for you. Of course, what we're now seeing is the rise of the commodity side of things, the scale-out side of things. And these solutions are probably a better fit for scaling with the hypervisor. They're certainly better because they can scale out in a similar way that you can scale out your storage solution, your hypervisor, without you having to tie the two together. It's very much a simpler path for migration, so if you need to replace technology over time, it's a very easy thing to do. And it, of course, can still be used for environments that have other storage needs. You don't have to dedicate that storage purely to your hypervisor. You could have separate servers, you could have mixed clusters, you could do lots of other things with it. One thing to bear in mind with this is, of course, many people might just want to deploy in commodity hardware and simplify their maintenance strategy. So if there's a requirement to, say, use absolutely the same hardware for both storage and for processor, some of the software solutions that sit on top of that commodity hardware could make a good fit for that. Finally, just one thing to say on the scale-out architectures is that the object solutions certainly look to be very interesting going forward, and potentially when things like vvols are supported fully, which is more of an object than in, say, a LUN is, these could be very interesting indeed, and we could see one platform that could support lots of different needs, that could support both the object side of things and the block side for hypervisors. So they've got some good potential in there. And with that slide, I shall pass back to Chris to see whether we have any questions there, Chris.
Yeah, I got a couple questions here sent to me via email, and thanks a lot for your presentation, Chris, by the way. I appreciate you doing that. Yeah, but we got a couple questions here via email. If you want to type in your question for Chris, you could type it in the Ask a Question box appearing on the left-hand side of your console. You could submit your question that way, and Chris will hopefully have a couple minutes here to answer them. But one of the questions that came in here, Chris, for you was, are you aware of any of the companies that you mentioned? Are any of those solutions, do they support Zen Server?
Yes, as an example, Zen is supported by, and is a hyper-converged solution. Let me think. I think I'm actually, hold on a second, I think I'm confusing KVM with Zen, so let's take a step back there. In terms of Zen support, I'm not specifically sure of any that absolutely give Zen support, but there's no reason why they wouldn't support Zen anyway, because the platform is pretty much standard as an open system platform. So I would expect most of them would support Zen.
I got a question here. What is the average size switch one would need to accommodate most of the replications, do you think?
Okay, so a lot of vendors are recommending that people use 10 gig switches. And really the number of ports you'd need on that switch would depend on the number of nodes you intend to support. Typically, you would have obviously at least one port per node. You'd have two for resiliency. So I think it's pretty much a simple case of looking at that and multiplying it up. Not all of the solutions require 10 gig, but clearly 10 gig is the thing that will give you that node-to-node performance.
Somebody had mentioned, somebody sent this in earlier, a couple of slides ago, you had mentioned that converged was a simpler solution with less moving parts typically for a small business. What if that business was growing? Would you recommend that they go a step up higher and do some non-commodity hardware? Somebody asked here that their business is growing and right now they're using converged. Do you suggest they would move up to a non-commodity hardware or commodity scale-out versions?
I think the way to think about it is to think about how far you'd be comfortable growing a single hyper-converged solution. So you may decide that you're happy with, say, 5, 6, 10 cluster members, and past that point, you'd be building a new cluster. Obviously, as soon as you do that, you're now in a position where you've got 2 clusters to manage, 2 sets of management, and you need to check with the vendor to see whether they would provide some sort of management interface that allows you to do the 2. And clearly at that point, you're now in a situation where you're introducing more complexity to the environment. So I guess, it's difficult to say without talking about individual users' environment and without knowing what they are. But I certainly look at it and say, if I'm starting to get to a position where I feel I need to deploy 2, 3, 4 hyper-converged solutions, then perhaps I need to look at whether storage standalone is a better solution at that point, because I may have issues about wanting to move workload between clusters. That becomes now a lot more complex, and that might be the opportunity to start looking at separating those out.
All right. Well, thank you so much, Chris, for taking your time out today. We really appreciate that. If you had a question for Chris and you couldn't think of it now, please feel free to submit it, and we'll have Chris follow up with you after the webcast is over. But really appreciate you all taking your time today, and people are already saying thank you, Chris, for the presentation in the Q&A. So they really enjoyed what you had to share today, Chris. So thank you so much for taking your time out. Today's webcast, Hyper-Converged or Compute and Storage Separated, which is best for virtualization, has been sponsored by StarWind and brought to you by Redmond Magazine. Thank you all for attending today's webcast, and we greatly appreciate it. Talk to you again soon, everybody. Take care.